Okay, so we are solving linear equations. We're going to talk about the properties. Y'all know these properties. They just sound different. Okay, so addition property of an equality. Addition property is also the same thing as like subtraction. This also works with subtraction. And the reason being is, y'all, adding a negative is the same thing as subtracting. And that's why adding and subtracting go together. Yes? So if I add C to this side of the equation, what do I have to do to the other side to keep it equal?
Add C.
Okay. So how would I solve this following that?
Plus X.
Not plus X. We don't want to move the X because there's only one X and it's already alone.
Oh, plus 4.
I want to get rid of this minus 4. How do I get rid of minus 4?
Plus 4.
Okay, so negative 4 plus 4 equals what? 0. And what am I left with on the left side? X equals, you were right, 11. So that's your addition or subtraction property. Because what if it was plus? What would you have done to get rid of it?
Minus.
Subtracted. So that's why addition and subtraction go together. Any questions with that? Okay, so what about multiplication? Well, if I multiply this side by C, what do I have to do this side to keep it equal? Multiply. So this one's a little tricky. Do y'all know how to get rid of a fraction by multiplying in one step? You multiply by the reciprocal. What's a reciprocal? Kind of. Not necessarily your opposite, but the flip. Okay, what does this look like flipped? So if I multiply both sides by 5 over 3, it will cancel. So what I want you to see is the top is considered your multiplication and the bottom is considered your division, sorry. And what does multiplication, what cancels multiplication? So multiply 5, divide 5, cancel. Multiply 3, divide 3, cancel. And that's why it works. So I have A equals, can we type that in our calculator?
Yes.
Yeah. And we get 12 times 5 over 3, and it equals 20. Pretty simple, yes? Those are the properties we're using today to solve. Yes? Cool. So look at A. Don't judge my numbering. It should be A, B, C, D, but it is what it is, okay? So first things first, my rule when solving is to make sure both sides are simplified before you start trying to move things to opposite sides. Because when you're trying to do both at the same time, it can get messy, okay? So can this side simplify? No. Can this side simplify? Yes. What's negative 3.2 minus 6.6?
Negative 9.8.
Yes, it's negative 9.8. Okay. Don't let decimals stress you out. Use your calculator. And I'm going to bring this side down because it didn't simplify. And the only letter I have is Y. Okay, so how do I get that Y by itself? Add what? 1.2. And I know that because I have Y minus 1.2, and the opposite of minus 1.2 is plus 1.2. So this zeroes out, and what am I left with on the left side? Y. And then negative 9.8 plus 1.2 is negative 8.6. Any questions with that? It's pretty simple. Okay, so let's look at D should be B. Okay, so again, we're going to cut it in half at the equal sign. Does either side need to simplify? Yeah, both sides, right? So what can I simplify on the left side? The 6x minus 5x. What's 6x minus 5x? X. Now, I'm going to write something in pencil. Do not write this down. Okay, what I'm writing in pencil, do not write it down. But this is a mistake I see a lot. I will see people start doing the opposite. Why is that wrong? Because what? Because they're still on the same side. That's what you said, right? It's because they're on the same side. When it's on the same side, you keep the same sign. Opposite side gets the opposite signs. Does that make sense? Same side, same sign. So positive and negative. That's why it became 1. Okay? Don't make that mistake. That's why my big thing that I'm going to push y'all to do is simplify before you start moving, because it kind of prevents that mistake. A lot of people start making that mistake when they're trying to do all the steps at once, and it becomes a mess. Okay, so I still have that plus 8 equals, and what's this side simplified? Yes. Now I have x plus 8 equals 5. I'm solving for x. So what do I have to get rid of to get x by itself? The plus 8. How do I get rid of plus 8? Minus 8. 8 minus 8 is 0. And I'm left with x equals negative 3. Now, on every single one of these, you can check your work. I will have an answer key for your practice, but you can check your work on your own also, which is important for your test, right? Or even on, which you're not getting tested over this for a while, but on your TSI practice test on Friday, like this is something that you can do to help you, because the TSI is multiple choice. So you can plug in negative 3 every time you see an x, but use the original. Because if you start using where you've already simplified, if you made a mistake, it still might be right, but you already made a mistake, so that's why. So we have 6 parentheses, negative 3. Always use a parentheses to plug in your x. Plus 8 minus 5 parentheses, negative 3. That's the left side of my equal sign, and it equals 5. So what do I want the right side to equal? Does 8 minus 3 equal 5? Mm-hmm. So did I do it correctly?
Yes.
Because they're equal, I did it correctly. Yes? Mm-hmm. Cool. So you can do that on all of these. Okay, so look at B. What do I need to do?
I need to get rid of that 4.
I need to get rid of what 4? What kind of 4?
Negative.
Negative 4. How do I get rid of that negative 4?
Plus 4.
Not plus. Why not?
Oh, goodbye.
If you had to read this, what's happening? It's negative 4 times x, right? There's no plus or minus in the middle, so I can't say it's adding or subtracting. Yes, it's a negative, but when there's no symbol, y'all, it's multiply. Can't see, but I put a dot. Okay? How do we get rid of multiplication? Division. So we're going to divide by the exact number in front. What number's in front of my x? So I'm going to divide by negative 4. This cancels, and I'm left with x equals what?
Negative 4.
Negative 4. Now here's my question. What's negative 4 divided by negative 4?
0.
No. 1. Do you notice that I used a line? Doesn't a line represent a 1, kind of? What is 8 minus 8? Do you notice I used a circle, like a 0? I do that on purpose, y'all. This because it equals 0. This because it equals 1. Okay, that's why I do that. I know that a lot of y'all don't, and that's fine. But I do that for a reason. Okay, look at E. What do you notice? How many terms are there? No. I think somebody said it. No. No. Yes. 1, 2, 3. What do all 3 terms have in common? A denominator of what? When every single term has the common denominator, guess what you get to do when it's an equation? Not add, but you can cancel it. And I'm going to prove to you why mathematically. You don't have to show me why every time you do it, but I want you to understand why. Because how do we get rid of, remember, fractions are just division. How do you get rid of division?
Multiply.
You multiply. So if I multiply both sides by 7, I did it to both sides to keep it equal, right? Well, multiplication cancels division. Multiplication cancels division. That's why you can do that. Does that make sense? So then I just get 3x equals 5 plus 2x. How do I solve that? Yeah, I'm solving for x. And I want to move the 2x, not the 3x, because the 3x is already alone. There's no constant by itself over there with it. So I'm going to do minus 2x minus 2x. And what's 3x minus 2x? So I get x equals 5. And again, I'm going to show you one more time that you can always check your work with these, even when variables are on both sides. So alpha y equals enter 3 over 7 times 5. So that's exactly what was there, x, and we said x is 5, right? And I get this fraction. So I should get the same fraction when I type it on the other side. Do they equal? Then we did it correctly. Does that make sense? Cool. Okay, last unit, I don't know if y'all remember, but a bunch of people kept telling me they wanted to cross multiply for something, but it was expressions, which means no equal sign, so you can't do that. However, here we can. But the only time you can cross multiply is when you have a single fraction equals a single fraction. See how this is one fraction? One fraction? That's why I can cross multiply. Here I wouldn't cross multiply because it's two fractions on this side and one on this side. Does that make sense? So I know this isn't a fraction, but what can I put on the bottom to make it a fraction? 1. And now I can cross multiply. So I have, well, 2 times 1 is 2, a plus 3. And then this is 3, 6a plus 2. Now it's not a fraction and it's a little simpler to solve. What do I need to do to solve it though? Distribute. I need to simplify both sides by distributing. So 3 times 6a is 18a. 3 times 2 is 6. 2 times a is 2a. 2 times 3 is 6. Now what? Huh? We can subtract 6. It doesn't matter what you move first. I always like to move my variables first, but in the end, it doesn't matter. What happens on both sides? They both cancel, but I still have a letter, so we're still solving. But I need those letters on the same side. So I'm going to do minus 2a minus 2a. What does this side equal? 0. So it's still a number. Is 0 a number?
Yes.
Can you have $0?
Yes.
Because it's a number. Okay, don't freak out. For some reason, y'all freak out when there's a 0. Okay, don't do that. What's 18a minus 2a?
16.
How would you solve this?
16.
Divide both sides by what? 16. We're trying to get a by itself. It's multiplying, so we're going to divide both sides by 16. And a equals what? 0. Remember, it's okay to have a 0 on top. That equals 0. It's not okay to have a 0 on bottom. That's undefined. So 0's on the top, so it's okay. We're good. Does that make sense? Any questions there?
No.
Okay, so look at F. What are we going to do on F?
Stand up like you said, up, down.
Yeah, we could do it just like this. We can cross multiply. So what's 5 times 2?
10.
And what's 3 times 4?
12.
Now what?
Do you multiply?
Distribute. Yeah, we're going to multiply. 10 times x is 10x. 10 times negative 6 is negative 60. 12 times x is 12x. 12 times 2 is 24. Now what?
I had a question. If you wanted to, you could switch those, right?
What do you mean?
Like, you know how like 12's on that side? You could put it on the other side.
You could put 12x plus 24 on this side and 10x
Yeah.
minus 60 on this. Yeah. So I always like to move my smallest variable first. Okay, so like on this one, I personally would have moved 2a first, but in the end, I wanted to show you that it doesn't matter what you move. So I always like to move my smallest variable, especially like eventually we're going to get into inequalities, y'all, and when you do that, it keeps it positive, which we like positives with inequalities. So that's why I try to create that habit now, so it's just a habit all the time. So 10x cancels, and we're left with negative 60 equals 2x plus 24. Now I know sometimes negatives are inevitable, but you can try. And I'm going to do minus 24. So we're always going to get rid of addition or subtraction first. And that gives me negative 84 equals 2x. What's my last step? Divide by 2. And that gives me x equals negative 42. Okay, the next two we're not going to go all the way through. There's just something I want to talk about, and then the special cases we're going to talk about, and then we're done. Cool? So I know it looks like there's a lot on the back, but I just want to talk about the special cases. So we're just going to cover one thing on these two, and then we're not going to go all the way through these, is what I'm saying. Okay, what would you do first on this one? Yeah, distribute on the left side, right? The right side simplify, but we have to simplify the left. So I would distribute. I would get 15 plus 5z. Now what would I do? Distribute the negative. Y'all, this is a big mistake people make. They don't distribute the negative. Minus 8z. And what's negative 8 or negative times 9? Negative 9. Now, a big mistake people make, don't write down what I'm putting in pencil, is they'll just write negative 8z plus 9. Is that correct? No, you have to distribute to both terms when there's a negative in front. Okay? So that's the only thing I really wanted to touch on this one. Any questions with that? What makes H ugly? The decimals, because there's decimals and then there's non-decimals. Now, I want you to realize A, the first one we did had decimals, but they were all decimals, so it really wasn't that bad, right? There wasn't a multiplication, there wasn't anything bad, it wasn't that bad. So you could technically solve this one with the decimals, no problem. But if that really stresses you out, can you get rid of the decimals? Yes. You just have to pay attention to what place value they are. Technically, you really don't even need to know that. But I'm going to quiz you, elementary quiz. What place value is this?
Tenths.
No, hundredths. Okay, here's the secret. Are you ready? There's 2 places. How many zeros are in 100? 2. How many places are here? So what place value is that? Tenths, because there's only 1 0, right? What place is this? Hundredth. What if there were 3 numbers? It would be thousands. Does that make sense? Okay, I'm pretty sure I didn't learn that until I was an adult, so just trying to help you all out. So what we can do is we can move the decimal. As long as I move the decimal on every single term, which this is a term, this is a term, and this is a term. Because remember, plus, minus, and equal signs separate terms. Multiplication doesn't. So multiplication can happen all day. Okay? As long as I move the decimal the same amount of times on every single term, it's still equal. So how many times do I need to move it here to get rid of it? 2. Isn't that the same thing as multiplying by 100? So aren't I just technically multiplying everything by 100? Not a big deal. So if I move it twice, what does it become? 25x. Plus, if I move that one twice, how many times do I need to move this one? Twice. I have to do it the same. I know it only needs once, but because I moved the other one twice, I have to move this one twice. What does it become? 10. Be super careful. You have to put a 0 in that empty loop. And then we move it twice. What does it become? 5. Does that look better for those of you that decimals really stress out? Yeah. Any questions with that? So we're not going to go all the way through it. That's how you would solve it. Cool? Cool. Last 2 are special cases. We are going to go through these because I need you to understand them. The simplifying part, I'm going to go a little quickly compared to like the beginning when I was like truly like walking out through it, because it's the same thing. So first things first, we're going to distribute, and I get negative 2x plus 10, and then I bring down that plus 10 on the outside. Can that still simplify? Yeah, what combines? Yeah, what's 10 plus 10? Okay, so the left side's fully simplified now, right? What do I do on the right side? Distribute. What can combine? The x's. What's negative 3x plus x? Negative 2x Okay, and now I'm simplified. So now I have to combine my letters. This is another reason I always move my letters first. Okay, so watch. When I do plus 2x to get rid of this, what happens on both sides? They zero out on both sides. I know I said 0 is a number, but we're solving for letters. If the letters are gone, can I continue solving?
No.
That's why we stop. Earlier, when we canceled out, we still had another letter, so it didn't matter, right? Both of my letters canceled. The variables cancel. And what's left? 20 equals negative 6. Is that true or false?
False.
False. So what do you think your solution is? No solution. This is the fancy symbol for no solution. You can just give me that, but you need to know that that means no solution. Now, if you write out no solution, that's totally fine too. I will accept both of those for the answer. So if it's false, 20 does not equal negative 6. So it doesn't matter what I plug in here. I can plug in any number in the world, any decimal, anything. It's never going to be equal. So there's no solution. Does that make sense? Okay, so let's look at this one. So again, I'm going to go quickly. The left side's already simplified. So I get this. What do you notice? They're the same. Now technically when you get problems like this, you can stop right here and tell me the answer. But I'm going to keep going one more step because I want you to understand what I'm saying. So if I do minus 12x, what happens again? The variables cancel on both sides. And what's left? Does negative 18 equal negative 18? So it's true. So what do you think your solution is? Infinite. It's infinitely many solutions. So yes, that's a lot to write. If I spelled it infinitely wrong, do not judge me. I teach math for a reason. So we call this IMS. If you want to write out infinitely many solutions every single time, I'll take it, but IMS is a lot easier to write. Any questions with that? Pretty simple, right? So special cases is when variables cancel on both sides. Not just on one side, but both sides, yes? Okay, one thing I want to show you on your practice. Please hold. I'll put that back up in just a second. Look on the back of your practice, number 15 through 18. Okay, it says why. Y'all, I don't teach English class. I don't want sentences. Okay, I want proof. Okay, and I'm not asking for you to solve this whole thing like you did on the other 12. Okay, if I'm asking you if negative 1's a solution, can you just plug it in and check it?
Yeah.
All I want from you is this. You can literally just do, okay, well, negative 3, plug it in, negative 1. And remember, I said use parentheses every time you're plugging in an x. So see how both times there was an x, I used parentheses and plugged in what it's asking as a solution? And then I'm going to type both sides of my calculator. 3, negative, oh, sorry, negative 3. Negative 3, parentheses, negative 1. Dang it. I'm really struggling here. What does that equal on the left? 4. And when I type the right side, I get negative 2, parentheses 4, parentheses negative 1, parentheses plus 2 parentheses. Lots of parentheses. What does it equal? Is it a solution?
Yes.
Does 4 equal 4? Yes. Now, what's different here than just a second ago with my special cases when I was solving? Did I just solve? Was this solving, or was I just checking work? So is it the same when you check work and when you solve? No. Y'all, checking work, if they're equal, that means it's a solution. Solving, if you get 4 equals 4, that means infinitely many solutions. Very different. Cool? Okay, cool. This is what you're working on. We don't have notes tomorrow, which is exciting. You'll have time to finish this and yesterday's practice.